Hey guys, welcome back to my channel. Today in this video we'll be solving this question. This is a very famous question, median of two sorted arrays. Let's try to understand what the question is saying. Given two sorted arrays, nums1 and nums2 of size m and n respectively, return the median of the two sorted arrays. Okay, and the overall runtime complexity should be O of log m plus n. Okay, so I think you guys might be knowing the brute force approach for solving this. The brute force approach for solving this is that we'll be taking an array and then we'll insert each and every element into it. Okay, I will be inserting the elements in that array in a sorted manner, and after that I will just find the median. Simple. Okay, that can be one approach, or else I can take two pointers, one for the nums1 array and one for the nums2 array, and initially they will be pointing at the first element, and after that they will move to forward, and if I find that I have reached the median position, then I will return that. Okay, so that can be the second approach. Now the final approach comes in, that we are going to use binary search for that. So let's try to understand how the approach is working. So let's take this array. I have two arrays. Array 1 is this 1 4 7 10 12, and 2 3 6 15 is the second array, correct? So let's try to find what is the median for this. Okay, 1 4 7 10 12 and 1 4 7. Sorry guys, I should say sorted. Okay, 1 2 3 4 6 7 10 12 and 15. So what is the median? I have 4 elements here, I have 4 elements here. 6 is the median guy. And if you see carefully, then you know every element to the left of median is lesser than or equal to the every element to the right of the median, right? This is median, right? That's why. So we can use this feature to calculate our median. Okay, and what will be the size of number of elements in my left? I can calculate that by just let's say the size of the array 1 is n1 and size of array 2 is n2. So what will be the number of elements in my left? It will be n1 plus n2 plus n1 plus n2 plus 1 by 2. Okay, this will be the size of my left array. Let me put it somewhere else. Let's say, yeah. So if you see carefully here, what I'm doing is that I have taken some elements from the array 1, right? I have taken 1 and 4 from array 1, and 2 and 3 are from array 2, and as well as what I'm going to do is that if both of my sides are equal, 4 elements are also here and 4 elements are also here, what I will be doing is that I will be taking this median to my left side. Okay, so that's why I have added a 1, so that I can my formula will fit in. That's why. So from array 2 I am taking 2 3 and 6. From array 1 I am taking 1 and 4, correct? This is what I am doing. Okay, after this so definitely what I'm thinking of doing is that I'm thinking of taking some elements from array 1, and suppose I took one element from array 1. I took one element from array 1, then how much elements I have to take from array 2? I have to take this is kind of n1 is what? N1 is 5 and n2 is 4. So 5 plus 4 plus 1 by 2 is what? 5, correct? 10 by 2 is 5. Yeah, so I need to have 5 elements to my left. So definitely I'm gonna take 4 elements for my left. Okay, so it will be 2 3 6 and 15. 2 3 Let's not take this example. Well, let's say I'm not taking this example because you might get confused at the very first time. So let's take 1 4 7 and let's take 2 and 3. So what I did is that I took first 1 4 and 7 and I took 2 and 3, correct. Let's call this part as left 1 because it's in the left, and let's call this left 2. What is the remaining for right, guys? Right portion, for right portion 10 12 is remaining and 6 and 15 is also remaining. So let's call them 10 12 as right 1, correct. 6 and 15 is right 2. So for I want to check if it is correct or not. I mean, the partition I have done, is it correct or not? For that, the conditions should be valid, and conditions should be such that if left 1 is lesser than or equals to R2 and left 2 is lesser than or equals to R1. This is a condition which will be true if it is a, I'm doing a correct partition. This condition will be true when I am doing a correct partition. So let's see if it is correct or not. Is 7 lesser than or equals to 6? So definitely it's not a correct partition. Not. L2 is lesser than or equals to R1? Yes. Okay. So definitely it's not a correct partition. So for that, now what I want is that I want this L1 to get reduced. So definitely I have to try something lesser number, some lesser values number. So definitely I'm not going to move to my right. Why? Because if I will move to my right, definitely I will get a higher value number, and that is what I don't want, right? That is what I don't want. I want a smaller value number. So definitely I have to move to left. So it means that if I am standing at here, I can decide where I have to go. So I can use binary search here. I know that I am not going to use any elements I'm not going to use any elements which are to my right position, right? I have to use to my left. So definitely we can use binary search here. Yes, you heard it right. We can use binary search. So I will try with this option. Firstly I tried with this, okay, 1 4 7. Now I will try with this 1 and 4. I will make a cut it here. If I will take 1 and 4 from the array 1, how many elements I have to take from array 2, 3 and 6? 3 elements I have to take. Okay, so this is what now it will be. Is it correct or not? Let's see. Okay, 1 4 for the left one, 2 3 6 for the left 2, and 7 10 and 12 for this guy. Okay, so 4 is lesser than or equals to L1 is lesser than or equals to R2. Yes, correct, it is. L2 is lesser than or equals to R1. Yes, it is correct. So this is a valid partition. This is a valid partition. If I will do a partition here, then definitely then it's a valid partition. So this is what I am going to use, right? So I hope you got the logic. Like let's still there are few things which I need to tell you. So what will be my searching area? So my start will be 0. I mean for binary search, if I want to implement, my start will be 0 and end will be n1, which is this. Sometimes it might happen that I'm not taking any element from here. So at that condition, for L1 to be valid, I have to take int min, correct? And sometimes it might happen that I'm not taking any elements from here. I'm not taking any elements from L2. So for that, in that condition, I have to take int min. Well, these are edge cases. I will tell you later on also. So let's try to understand another thing. Okay. So suppose start will be what? My start will be 0 and end will be what? N1. For n1, currently n1 is what? 0 1 2 3 and 4. Okay, this is my n1 currently. 0 1 2 3 4. Yeah, I will say what is my cut 1. Cut 1 is what? S plus e by 2. Simple. I will make a cut at this guy. S plus e by 2 is what? 0 plus 4 by 2, 2. So it means that I am taking two elements from here. And what is my left one? Left one will be nums1 of cut 1 minus 1. 2 minus 1. Okay, so it will point to this 1 and 4. Sometimes it will happen that my cut 1 is 0. At that time I have to say, if my cut 1 is 0 and cut 1 minus 1, it will be minus 1, and it will throw error. Okay, so at that condition I have to take a int min. So I will take int min. These are the edge cases I have to handle. Okay, so what will be L2? I have to take for L2 to define, I have to take I have to know, I want to know what is my cut 2. Okay, so I will calculate the cut 2 as well. So it will be n1 plus n2 plus 1 by 2 minus cut 1. This is what this function will give me the number of elements to be on the left, right? So it is currently 10 by 2, I mean 5. And what is cut 1? I am taking 2 elements from my array 1. Then how much elements I have to do? I have to take 3 elements from array 2, definitely. So cut 2 is what? 3. And L2 will be what? Nums of 2 cut 2 minus 1. Why cut 2 minus 1? It's 3. Then I am taking 3 elements. Then I have to take 0 1 2. I am taking up to these elements only. This is 3. Okay, 0 based indexing. Now let's try to find out what will be my R1. This is R1. Okay, so let's try to find out R1 will be what? Simple. It's if I'm taking what was my cut 1? Cut 1 was 2. I will be taking R1 is this, correct? Nums 1, this will be cut 1, and R2 will be what? Nums 2, I mean sorry, it is nums 1. Nums 2, this will be cut 2, correct? Now I have to check if it is valid or not. So I will be I hope you got this. How am I doing partition? Okay, and how I am finding L1, L2 and R1 and R2. Let's try to do a dry run on this example. 1 to this 4 7. Okay, I will take this as an example. Okay, so every time I'm going to calculate cut 1 and cut 2, definitely. Let's say this cut 1 and cut 2. Okay, start is 0, end is 0. What is cut 1? It is 2 currently. And let's erase this. 0 1 2 3. Okay, cut 2 will be what? It will be 5 minus 2, 3. 5 minus 2, which is 3. So what will be L1? So I will draw each of the process in to my left side. Okay, so for cut 1 is 2. Okay, so what will be my L1? L1 will be nums 1 of cut 1 minus 1. Cut 1 is what? 2. 2 minus 1, this 1 4 it will be. L1 will be 4. L2 will be what? Nums 2 cut 2 minus 1. This is nums 2. Well, let me write it nums 1 and nums 2 as well. Nums 1, nums 2, correct? Nums 2, L2 will be nums 2 cut 2 minus 1. Cut 2 is what? 3. 3 minus 1, 2. So definitely 6 is my L2. What is R1? R1 is nums 1 cut 1. Nums 1 cut 1. Cut 1 is what? 2. So 7 is R1. R2 is what? Nums 2 cut 2. Correct. I have explained you this earlier. I have explained you this. Okay. So cut 2 is 3. 0 1 2 3. 15 is my R2. Okay. and I hope you know what is R1, R2, left one and left two. These are left one, left one. Okay. So let's check if it is a valid or not. If it is a valid partition or not. Is left one lesser than or equals to R2? And is left 2 lesser than or equals to R1? You might be thinking why I'm not checking with is left 1 lesser than or equals to right 1. I'm not going to check that because I know it will be always lesser than or equals to R1 because I am taking the cut. I am taking left 1 and R1 from a sorted array, correct? So I'm not checking that. I have to check is it valid or not. I mean, is it L1 lesser than or equals to R2 or not, and I will check is it like L2 is lesser than or equals to R1 or not. So check. Okay, 4 is lesser than or 15, correct. Is 6 lesser than or equals to 7? This is also correct. So it's a valid partition, definitely. Yeah. So my left one, let me write the whole array. 1, 4, and left 2 will be what? 2, 3, and 6. R1 is what? 7, 10, and 12. R2 is only 15. This is my correct partition. As you can see, to my left I have 1 and 4. I have 2, 3, and 6, and 7, 10, 12, and 15 are to my right. Okay, yeah. So let's code it now. Okay, int n1 is equals to nums1 dot size. Okay, n2 equals to nums2 dot size. And let's assume that n1 is lesser than n2, and if it might happen that n2 is sometimes lesser than n1. So what I will try to do is that if I know that m1, if I will try to use a binary search on n1, and if n1 is lesser than n2, then my complexity will reduce. Okay, so that's why I'm doing it on n1, but it might happen that n2 is lesser than n1, so I will check also that. In that case, I will say return find median sorted arrays. Okay, I will pass nums1 is nums2, nums2 and nums1. Okay, so let's start is equals to 0 and end is equals to n1, correct, using binary search. What is cut1? I stated you earlier as plus e minus simple formula of finding mid. Okay, s plus e minus s by 2. What is cut2? n1 plus n2 plus 1 divided by 2 minus cut1. This is cut2, correct. Now let's try to find out L1, L2, R1 and R2. Int L1 is what? Is cut1 is equals to 0? If it is so, then I have to take cut1. I mean my L1 will be int min. Why int min? I am trying to validate this condition. Okay, I am trying to match this condition. My L1 should be lesser than R2. So I am taking the minimum one here. So it might sometimes happen that I am not taking any element from array 1. Okay, so at that condition I have to take L1 as a int min. Else I will take nums1 of cut1 minus 1. Okay, L2 is what? Cut2. It can also go to 0. In that case I will take int min. So cut2 minus 1. What is R1? Let's try to find R1. Sometimes it might happen that I'm taking each and every element. I mean, there is nothing left for my R1, and at that time my cut1 will be equals to n1. So if it happens, if there is no element for R1, then I will try to take int max as R2. R1 and R2 both. Okay, why? Because I want to match this condition. I am taking greatest of all number, int max, so that L1 should always be lesser than R2. So if it is so, cut1 is equals to n1, so I will say take int max this is nums1 and cut1, I would say. Int r2 if cut2 is equals to n2, it might happen. Okay, I already told you, int max nums2 cut2, correct. Let's try to check if it is a valid condition or not, valid partition or not, I mean. Left one is lesser than or equals to r2 and left 2 is lesser than or equals to r1. Okay, r2 and left 2 is lesser than or equals to r1. So now if it is a valid one, then I have to check what is the size, and with respect to that I will be returning the median. Okay, if size is such that it is a odd number, see, it was an odd number, 4 plus 1 plus 4, it's 9. Okay, and it's an odd number. At that case, what I am going to do is that I know that the median will be lying to my left portion. I know that median will be lying to my left portion. So I will take max of L1 and L2 and I will return that. So let's say let's say n1 plus n2 plus 1. Sorry, I think I did a mistake. This is n1. Okay, yeah, I'm taking that. If it is a modulus 2 is not equals to 0, it means it's a odd. So I will be returning the max of L1 and L2. Okay, else I know that what I have to return. It means that I have to suppose I had, let's think of example where I have 5 here. Okay, 1 2 3 4 and 5. Now I have 5 elements here and I have 5 elements here. What I am going to return is that I am going to return 5 plus 6 divided by 2, which is 11 divided by 2. Yeah, this is what I am going to return. Okay, so yeah, it will be 5. Yeah, so for that to find, I have to take maximum from my left. Okay, maximum of L1 and L2. I will take max of L1 and L2 plus I will take minimum of R1 and R2. Why minimum? I want to find this value. Right? So that's why I have to take the minimum of R1 and R2. If I will take maximum, then this value will get returned. But I want this, so I will take minimum of R1 and R2. And I will divide it by 2.0. Simple. Let's do it. Return max of L1 comma L2. I think I should take a bracket. Max of L1 comma L2 plus minimum of R1 comma R2. Okay, and let's divide it by 2.0. I have to return it in double. Okay, that's why I'm doing. Now this condition might arise that my partition is not correct. Let's say I think let's take this as an example. Okay, what I did is this. Let's say I'm taking this as an example, and I did partitionate here. I did partitionate and my cut 1 is 3, suppose. Okay, so what will L1 will be 7. What will be L2 will be 3, right? 5 elements. Okay, R1 is what? Now R1 will be 10, R2 will be 6, correct? So let's try to find is the condition value. Is L1 lesser than or equals to R2? No, this is not valid. I mean, okay, L1 is lesser than or equals to R2. No. So I want to make this L1 lower value. So definitely I have to move to my left. So what I will try to do is that and equals to cut 1 minus 1, mid minus 1 also. Okay. So if my L1 is lesser than or equals to R2, I will say move my, let's try to search the left portion, mid minus 1, sorry, cut 1 minus 1, I will say. Else I know that I have to go where? I have to go to the right portion, right? So let me give you an example of this also, for this also, yeah. And let's say return minus 1, I'm not. Let me give you example of this also. Okay, I think suppose I am taking each and every element. My L2 is 2, 3, 6 and 15. 2, 3, 6 and 15. Let's say my L2 is 2, 3, 6 and 15. And I'm not taking any element from here. It's int mean. What will be my R1? R1 will be 1, 4, 7, this, okay. 1, 4, 7, 10 and 12. And it will be int max here. So this L1 is here, L1 is lesser than R2. It is correct. It is correct. L1 is lesser than R2. Oh, sorry, I think I should have written here L1 if L1 is greater than R2. That's why, sorry, yeah. This condition is correct. But if you closely see, then this is my L2. Is L2 lesser than or equals to R1? I don't think so. 15 is not lesser than or equals to 1, yeah. 15 and this is R1. So definitely what I have to do is that I have to make this 15 a value lesser one. Okay, so how can I do that? So definitely I have to move to my left. If I want to move to my left, I have to take some elements from there. Okay, so to take some elements, I have to increase my s. Correct. So I will increase my s definitely. Or else you can think in terms of that. I have to increase this value. So to increase this value, I have to I have to put some elements from here of R1. I have to put some elements from here to this guy. So to put that thing, I have to definitely increase my s. Okay, I will increase my s value. Start that at what I mean to say. So yeah, that is why I have written s equals to cut 1 plus 1. This is a correct partition. So what is the time complexity? It's just O of log of minimum of n1 and comma n2. Let's try to run it. Yeah. I got a wrong solution. I might have done some mistake. Let me check. Okay.
हाँ यार
Next year. So this is one down. Output shouldn't be this, correct? What mistake I did? पूरी वीडियो बनाई साला टॉन्ग हो गया, पता नहीं क्या हो गया। सब तो सही है। ये भी लिख लेंगे, उसमें क्या। वही इंटू 1.0 मल्टीप्लाई नहीं करा ना। L1 and L1 ये तो मिस्टेक करा मैंने। आई मीन यहाँ पे चेक कर, इट शुडंट बी L1 यार। अभी यार इसको एडिट करना पड़ेगा अगर मैं वो करूँगा तो, पर इतना मेहनत यार बर्बाद जाएगा, नहीं तो इट विल गो वेस्ट। So guys, I have found what was the mistake. What I did was I returned max of L1 comma L2. I mean I was returning max of L1 comma L1. Okay, but it should be max of L1 comma L2. Let's try to run it. I don't need to do this into 1.0. Okay, I can like that. I can write the code like this also, but still I don't need. Okay, simply let's try to submit it now. So now it is submitted. I hope you guys understood the solution. Thank you for watching the video.